On a Saturday morning in New Orleans, 112 workers were inside a building that had already failed. The beams holding up the 16th floor were carrying 4 times the load they were designed for. The concrete above them had been curing for 3 days when it needed 3 weeks. And the inspector who was supposed to catch all of it was not there. His truck was across town. We know, because someone checked the GPS. To understand what happened at 1031 Canal Street, you have to understand what that address meant to New Orleans. Canal Street is the city's main commercial spine, the dividing line between the French Quarter and the Central Business District, a boulevard wide enough to feel like a civic statement. For years, the north side of that block had sat underutilized, a gap in the streetscape that city planners and developers had been eyeing for the better part of a decade. When a project finally came together to fill it, it was not a modest one. And one of the decisions made early in that project, before a single beam was redesigned, is the one that will matter most by the time we reach the 16th floor. The project that would become the Hard Rock Hotel New Orleans was not a small speculative build. The plan called for 350 hotel rooms, 65 residential units ranging from 1 to 3 bedrooms available for purchase, an upscale restaurant, a 12,000 square foot event space, and a 400-space parking garage, all stacked into an 18-story mixed-use tower with an $85 million construction budget. That is the kind of project that gets ribbon-cutting ceremonies and mayoral press releases. It is also the kind of project where the pressure to hit a delivery date is enormous, where every week of delay costs money, and where the people making decisions about concrete and steel are acutely aware of that pressure. Before the Hard Rock branding arrived, the site had already been through one development cycle. A previous structure on the lot was demolished to clear the way, and the height, massing, and general design of the new tower had already been approved through the city's planning process. When the project was repackaged as a Hard Rock Hotel, those approvals carried forward. The building's footprint, its relationship to the street, its floor count, all of that had been signed off before the hotel flag was attached. What this means is that the structural design was not starting from a blank sheet when the Hard Rock deal came together. But by late 2019, that locked framework was about to face a test it was never designed to withstand. By late 2019, the building at 1031 Canal Street was close enough to finished that you could see it becoming what it was supposed to be. The upper floors were being completed, interior work was underway on the lower levels, and the project was in that final stretch where the end feels tangible. In construction, this phase has a particular quality to it. The schedule pressure is at its highest because the finish line is visible. The workforce is dense because multiple trades are working simultaneously, and the decisions being made are the ones that determine whether the building actually performs the way it was designed to. It is also, as it turns out, the most structurally dangerous phase of a concrete high-rise construction, for reasons that will become very specific very quickly. Belter Bermudez was a steelworker. On October 12, 2019, he was working on the 17th floor of the Hard Rock Hotel Tower, one level directly below what would become the primary failure point. That positioning matters because Bermudez was not a distant witness. He was inside the building, close enough to the 16th floor to observe the construction sequence that preceded the collapse, and close enough to the failure zone that his survival was not guaranteed. In the weeks and months after the collapse, Bermudez would provide investigators and journalists with something more valuable than eyewitness accounts of the collapse itself. He provided a precise, first-hand timeline of the decisions made in the 8 days before it happened. Saturday, October 12, 2019. The time is approximately 9:12 in the morning, It is a weekend, which means the workforce on site is smaller than a weekday crew, but 112 workers are still inside the building. The upper floors of the tower begin to move. Not in the gradual, groaning way that a structure under sustained overload sometimes behaves, but in the sudden, cascading way that happens when a critical structural member reaches its absolute limit and transfers its load to members that are equally incapable of carrying it. The 16th floor is where the failure initiates. What happens next takes seconds. From ground level, the collapse of the upper floors of a concrete high-rise does not look like the controlled demolitions you have seen on video. It does not implode neatly inward. It sheds. Floors separate from columns, concrete slabs break apart, steel members twist and pull free of their connections, and the debris field extends outward from the building's footprint. For the 112 workers inside, the experience would have depended entirely on where they were standing when the 16th floor gave way. Workers on lower floors had more time. Workers on the upper floors, near the failure zone, had almost none. The building did not announce itself. It simply stopped being a building. 111 workers made it out. 3 did not. That asymmetry, 111 survivors against 3 fatalities, is not evidence that the collapse was minor or that the building performed well. It is evidence of something more specific. The collapse was fast enough to trap 3 people where they stood, but not so instantaneous that every person in the building was lost. The 111 who escaped did so because of where they happened to be when the failure initiated, not because of any safety system that functioned as designed. The 3 who did not escape were in the wrong location at the wrong moment, and the structure gave them no time to be anywhere else. Proximity to the failure point was the only variable that mattered. When news of the collapse broke on the morning of October 12, the families of the workers inside began making their way to Canal Street. Among them was the wife of one of the 3 men who had not come out. She arrived at the scene and she made a declaration that anyone who has ever waited for news they already know is coming will recognize immediately. She vowed to wait as long as it took. That sentence contains an entire universe of what it means to be on the outside of a disaster that has already decided its outcome. She did not know yet what waiting would mean. She did not know that for some families, the wait would be measured in days, and for others, in something much longer. One body was recovered on October 12, the same day as the collapse. The wife who had come to Canal Street and vowed to wait was still there when it happened. She watched. That is the kind of detail that does not fit neatly into an engineering post-mortem, but it belongs in this story because it is the human consequence of every decision we are about to trace backward through the paper trail. The other 2 workers remained where they had fallen. Their bodies could not be recovered that day, or the next day, or for an extended period after that, because the structure that had killed them was still too unstable for recovery teams to enter safely. The building that had failed to protect them in life continued to prevent them from being brought home in death. The reason recovery teams could not enter the structure immediately is not bureaucratic caution. It is structural physics. When a high-rise floor system fails partially, the remaining structure is not in a stable equilibrium. It is in a temporary one. The weight that the failed members were carrying has been redistributed to adjacent elements that may themselves be at or near their load limits. Additional debris loads from the collapse add to that. The result is a structure that is actively seeking its next failure point, and the people best qualified to understand that, the structural engineers who eventually helped with demolition, were the ones who determined that entering the building was not survivable for rescuers. The collapse did not end on October 12. It just paused. The footage of the collapse exists, the timeline exists, the GPS records exist, the worker testimony exists, the engineering analysis exists. What this case offers, which many structural failures do not, is a nearly complete paper trail from the decision that started the failure chain to the moment the 16th floor gave way. Most disasters of this kind involve some ambiguity, some missing document, some disputed account. The Hard Rock collapse in New Orleans is not that kind of story. It is the kind of story where the further back you follow the trail, the clearer the picture becomes. And the clearer the picture becomes, the harder it is to describe what happened as anything other than a series of choices. So let us follow it backward, starting with the steel. When structural engineers analyzed the video evidence of the collapse, they identified the primary failure point with precision. The steel beams beneath the 16th floor gave way first. Not the concrete, not the connections, not the columns, the beams under the 16th floor. That specificity matters because it tells you where in the structural system the failure initiated, and it points directly at the element of the design that was most compromised. In a properly designed and constructed floor system, the beams are sized to carry the dead load of the concrete slab above them, plus the live load of occupants and contents, plus a safety factor. At the Hard Rock site, the beams under the 16th floor were not doing that. They were doing something else entirely. The structural engineer who helped with the demolition of the Hard Rock Tower and who analyzed the collapse video described the beams beneath the 16th floor as being 300% overstressed. That phrase requires translation because it is easy to hear it as a large number and move on. 300% overstressed does not mean the beams were carrying 3 times their design load. It means they were carrying 4 times their design load. Here is the arithmetic. A beam at 100% of its design capacity is at its limit. Add 300% more stress on top of that, and you are at 400% of design capacity. 4 times the load the beam was engineered to carry. This is not a marginal engineering error. This is not a rounding issue or a conservative factor that got slightly miscalculated. This is a beam that was mathematically incapable of doing the job it was assigned. There is a common assumption about structural failures that this case directly contradicts. The assumption is that when a building collapses, something went wrong with the materials. Bad concrete, brittle steel, a corroded connection. The Hard Rock collapse was not that. The beams that failed were not defective. They were not improperly installed. They were not damaged by weather or time or an unexpected load event. They were simply not strong enough for the load they were asked to carry, not because of how they were made, but because of how they were specified. The failure was in the math that preceded the fabrication, not in the fabrication itself. You could have built those beams perfectly, and they still would have failed, because the numbers that defined them were wrong. The sources that document this collapse refer specifically to redesigned beams and newly designed beams. That language is precise and it is significant. It does not describe the original structural design as flawed. It describes a change that was made during construction, a mid-project modification that produced beams with inadequate load capacity. The original design had presumably been reviewed and approved as part of the planning process. The redesigned beams were something else, a change introduced after construction was underway, with a different specification and with consequences that the 16th floor would eventually demonstrate with complete finality. To understand how such a redesign made it past the people responsible for catching it, you need to understand value engineering. To understand how a structural redesign happens mid-construction, you need to understand a practice called value engineering. The term sounds technical and neutral, But in practice, it describes a specific kind of conversation that happens on nearly every large construction project. Someone reviews the budget, identifies a line item that looks expensive, and proposes a cheaper alternative that is supposed to deliver the same performance. Sometimes value engineering is legitimate and well managed. A different fastener system, a revised facade panel, a modified MEP routing. But when value engineering reaches into primary structural members, the load-bearing elements that hold the building up, the calculus changes entirely. Because the performance requirement for a structural beam is not aesthetic or functional, it is mathematical, and math does not negotiate. Here is the question that sits at the center of the beam redesign story and that the available sources do not fully resolve. Who approved the new beam specifications? In a properly managed construction project, a change to primary structural members requires a formal change order, a review by the structural engineer of record, a revised set of stamped drawings, and approval from the relevant building authority. That process exists specifically to prevent a cost-saving substitution from producing a beam that is 300% overstressed. If that process was followed at the hard rock site, then someone with engineering credentials looked at the new beam specs and signed off on them, which raises a different set of questions entirely. If that process was not followed, then the redesigned beams went into the field without the review that might have caught the problem before a single piece of steel was placed. This is the point in the story where I want to be direct with you about what the record does and does not contain. The sources that document the hard rock collapse confirm the beam redesign, confirm the 300% overstress figure, and confirm that the redesigned beams lacked adequate load capacity. What they do not confirm, at least not in the documentation available for this analysis, is the identity of the general contractor, the structural engineer of record, or the specific approval chain for the beam modification. Those are not small gaps. They are the gaps that a criminal investigation or a civil trial would be designed to fill. What we can say with confidence is that beams carrying 4 times their design load were installed in a building that 112 people were working in, and that the paper trail explaining exactly how that happened has not been fully made public. That matters, and we will come back to why. So let us go back to the beginning of the concrete timeline, because this is where the paper trail gets undeniable. On October 4, 2019, workers on the Hard Rock Hotel construction site poured concrete for the 18th floor slab, that is the topmost occupied level of an 18-story tower. The freshly poured concrete sat wet and heavy above beams that were already, according to the engineering analysis, carrying 4 times the load they were designed to handle. The clock started ticking the moment that concrete left the chute. Here is a detail that does not get enough attention. The city inspector approved the 18th floor pour on October 1, 3 full days before the concrete was actually placed. That sequence matters. The approval was not a response to conditions on the day of the pour. It was a pre-authorization, a rubber stamp issued before the work even happened. Whether the inspector physically verified site readiness on October 1 is one question. Whether anyone verified it on October 4th, the day the concrete actually went down, is a different question entirely, and the record does not give us a clean answer. 3 days after the pour, on October 7, 2019, workers removed the temporary support posts holding up the freshly poured 18th floor slab. 3 days. The concrete had been setting for 72 hours. It was not yet the color of finished concrete. It had not yet reached anything close to its design compressive strength, and the crew pulled the shoring. The American Concrete Institute publishes a standard specifically because engineers already knew what happens when you remove supports from concrete that is not yet ready. The American Concrete Institute publishes Standard Number 347. It is not a suggestion. It is not a guideline that contractors weigh against their schedule. It is the codified minimum standard for shoring removal in concrete construction, and it exists because engineers learned, through failures, that freshly poured concrete is deceptively fragile. Standard number 347 requires a minimum of 21 days of curing before temporary supports are removed from a concrete floor slab. That number is not arbitrary. Have you ever ignored a safety rule because you were in a hurry? Share what happened in the comments. That concrete curing timeline was not a suggestion, and the gap between what the standard required and what the project attempted is staggering. Let us put the numbers side by side because the gap is staggering. The industry standard requires 21 days minimum. Some engineers cite 14 days as an absolute bare minimum under ideal conditions. The Hard Rock site removed shoring after 3 days. That means the supports came out somewhere between 11 and 18 days early, depending on which threshold you apply. At 3 days of curing, concrete has achieved a fraction of its design compressive strength, perhaps 30 to 40% under favorable conditions, and the conditions on an open high-rise floor in October are not laboratory conditions. Belter Bermudez was a steelworker assigned to the 17th floor, close enough to watch what happened next. Belter Bermudez was a steelworker assigned to the 17th floor of the Hard Rock Hotel project. He was there on October 4th when the 18th floor concrete went down. He was there on October 7th when the shoring came out, and he was there on October 12th when the building moved. His testimony to investigators and journalists provided the specific dates that anchored the entire timeline. Without Bermudez, the sequence of pour, removal, and collapse might have remained disputed. Because of him, it is documented. The arithmetic of what those decisions meant, hour by hour, is almost brutally simple. The arithmetic here is almost brutally simple. Concrete poured October 4. Supports removed October 7. Building collapses October 12. That is a 5-day gap between the removal of the shoring and the moment the upper floors began to move. 5 days. The structure absorbed the transferred load, held it briefly, and then gave way. That 5-day window is not a sign that the removal was borderline acceptable. There is a counterintuitive engineering concept at work here, one that explains why the building did not fail all at once. There is a counterintuitive engineering concept at work here. When a structure is overloaded, it does not always fail instantly. Steel beams can deform, redistribute stress, and hold a load beyond their rated capacity for a period of time before reaching the point of catastrophic fracture. This is called plastic deformation, and it can look, from the outside, like the building is fine. The Hard Rock's 16th floor beams were bending under a load 4 times their design limit. The concrete above them was gaining strength by the hour, but nowhere near fast enough. The structure was not stable. On the morning of October 12, that slow motion became something else entirely, and investigators would later piece together why. This is the compound problem that investigators pieced together from the wreckage. The overstressed beams and the undercured concrete were not 2 separate issues that happened to coincide. They were 2 simultaneous loads pressing against a structure that had been compromised at the design stage and then further weakened at the construction stage. The beams could not carry the weight above them, even under ideal conditions. The concrete was adding dead load before it had the strength to act as a structural element in its own right. These 2 failures did not add together. They multiplied. Most people assume a building under construction becomes safer as it gets closer to completion, but the Hard Rock was approaching its most dangerous moment. Most people assume that a building under construction becomes safer as it gets closer to completion. More floors poured, more structure in place, more of the design realized. The Hard Rock Hotel inverts that assumption entirely. The 18th floor concrete pour was the final major dead load event on the structure. It was the moment of maximum weight, sitting on beams that could not carry it, above concrete that had not cured, with shoring that had already been removed. Completion percentage is irrelevant when structural capacity has been exceeded. The building was not almost done. Every major construction project in New Orleans operates under the oversight of the city's building inspection department, and someone was supposed to be watching. Every major construction project in New Orleans operates under the oversight of the city's building inspection department. Inspectors are assigned to projects, they visit sites at key construction milestones, they sign off on work before the next phase can proceed. This system exists specifically to catch what contractors and developers miss or choose to ignore. It is the external check on a process where financial incentives run almost entirely in the direction of speed and cost reduction. The Hard Rock Hotel had inspectors assigned to it. Reports were filed. Approvals were logged, but one inspector assigned to the project saw the reports and had the authority to stop what was happening on the ground. Eric Treadaway was a New Orleans building inspector assigned to the Hard Rock Hotel project at 1031 Canal Street. His name appears on filed inspection reports covering critical construction phases at the site. In the building inspection system, a filed report with an inspector's name on it is a statement of fact. I was there, I reviewed the work, I found it acceptable, or I flagged a concern. Treadaway's reports indicated he had been on site. They indicated the work had been reviewed. Local media obtained vehicle fleet GPS records from the city of New Orleans, and they revealed something the paperwork had hidden. Local media obtained vehicle fleet GPS records from the city of New Orleans. These are the same records that municipal governments use to track their vehicle fleets for maintenance scheduling and accountability purposes. When journalists cross-referenced Treadaway's GPS location data against the dates and times of his filed inspection reports for the Hard Rock Hotel site, the records did not align. On days when inspection reports indicated he had been at 1031 Canal Street, his city vehicle was somewhere else entirely. The GPS data did not suggest he arrived late or left early. It placed him off-site when the report said he was on-site. The GPS records did not reveal one missed inspection, and the pattern they exposed raises a question about what oversight actually looked like. The GPS records did not reveal one missed inspection. They revealed a pattern. According to reporting, the falsified inspections at the Hard Rock Hotel site were documented months before the October 12 collapse. That means Treadaway, or whoever was responsible for filing those reports, was creating a fictional record of oversight across multiple construction phases, across multiple milestones, across the entire period when the beam redesign was being implemented and the upper floors were being formed. Every falsified report represented a phase of construction that proceeded without the external verification the city's inspection system was designed to provide. The fraud was not a last-minute shortcut. Yet a building inspector who physically visited the site during the critical October window had multiple opportunities to intervene. A building inspector who physically visited the Hard Rock site during the critical October window had multiple opportunities to intervene. A competent inspection of the structural steel could have flagged the beam specifications against the approved drawings and identified the discrepancy between the redesigned members and the load they were being asked to carry. An inspection on October 7 could have observed the shoring being removed from 3-day-old concrete and cited the crew on the spot under ACI Standard number 347. An inspection at any point in the months prior could have documented the unlicensed workers and triggered a stop work order. Any one of those interventions might have changed what happened on October 12. Think about what a building inspection report actually does in the construction process, because that answer explains why the absence of them mattered so much. Think about what a building inspection report actually does in the construction process. It is a gate. Work cannot legally proceed past certain milestones without an approved inspection. When an inspector signs off, they are opening that gate and allowing the project to move forward. When Treataway's name appeared on reports for work he did not inspect, those gates opened anyway. The beam redesign moved forward. The concrete pour was approved. The shoring came down. Each falsified report was not just a piece of fraud. It was a green light on a corridor that led, step by step, directly to the 16th floor of a building that was about to fall. Have you ever worked on a project where you knew the oversight was missing, but nobody said anything out loud? I would be curious to hear about it in the comments. For the 18th floor pour, before the shoring came down, before October 12, workers on the Hard Rock Hotel project had already raised concerns. Documented worker complaints described project leaders employing unlicensed and underqualified electricians on the site. These were not anonymous tips. These were complaints from people working inside the building, people who could see that the standards being applied to one trade were not the standards required by law. Unlicensed electricians on a construction site represent a regulatory violation, a safety risk, and a signal about how the project's leadership viewed compliance in general. The complaints existed in the record before the collapse. What matters is understanding how those concerns moved through the system and where the chain of responsibility broke. This is where the analysis requires some precision, because the unlicensed electricians are often cited as evidence of general negligence without being connected to the structural failure. That connection is not direct. Electrical work does not load steel beams. Unlicensed electricians did not redesign the structural members or remove the shoring posts, but their presence on the site is a diagnostic. It tells you that the project's leadership had established a pattern of substituting unqualified personnel for qualified ones when it reduced costs or schedule pressure. That pattern, applied to structural engineering decisions, is exactly how you end up with beams that are mathematically incapable of carrying the load above them. The electricians are a symptom. To understand how this happened, we need to examine the 4 separate systems that failed at the Hard Rock Hotel. Let us lay out the 4 systems that failed at the Hard Rock Hotel, because this is the part that separates this collapse from a simple construction accident. First, the engineering layer. Beams were redesigned mid-project, and the new specifications could not support the load above the 16th floor. Second, the construction practice layer. Temporary supports were removed from concrete that had cured for 3 days instead of the required 21. Third, the regulatory layer. Building inspections were falsified by an inspector whose GPS records placed him off-site during filed reports. Fourth, the labor oversight layer. Unlicensed and underqualified workers were employed on the project despite documented complaints. 4 separate systems, 4 separate failure modes, all active simultaneously on the same site. 4 separate systems do not fail simultaneously by accident. They fail simultaneously because they exist inside the same decision-making environment. The beam redesign happened because someone decided the original specifications were too expensive or too slow to procure. The shoring came down early because someone decided the schedule mattered more than the curing time. The inspections were falsified because someone decided that actual site visits were an inconvenience. The unlicensed electricians were hired because someone decided that licensing requirements were a cost to be avoided. Each of these decisions was made by a person, approved by a process, and enabled by an oversight system that was not functioning. This was not 4 accidents. This was one culture, producing 4 entirely predictable outcomes. So let us say it plainly because the evidence demands it. 3 workers died on a Saturday morning in New Orleans, not because a beam cracked unexpectedly, not because concrete is an imperfect material, and not because construction is inherently dangerous. They died because someone redesigned structural members without adequate load capacity, because someone pulled temporary supports after 3 days instead of 21, and because the inspector assigned to catch those decisions was across town. The structure did not fail. The decisions did. Demolition of the Hard Rock site began in 2020, and it was during that process that structural engineers got their closest look at what the building had actually become. Analysts reviewed video footage of the collapse, slowing it down, mapping the sequence of failure floor by floor. What they found confirmed what the physics had already suggested. The failure initiated at the 16th floor, propagated upward through the structure, and the speed of that propagation told its own story about how little reserve capacity remained in the system when the first member gave way. In October 2021, 2 years after the collapse, experts went on record with a conclusion that the engineering community had already suspected, but that had not yet been formally stated for public consumption. The redesigned beams beneath the 16th floor were operating at 300% overstress. That is not a figure that leaves room for interpretation. Beams carrying 4 times their rated design load are not beams that might fail under adverse conditions. They are beams that will fail. The only variable is when. In this case, the answer was 5 days after the temporary supports came down. 2 of the 3 workers killed on October 12 remained inside the unstable rubble for an extended period after the collapse. The structure was too dangerous to enter for recovery operations, meaning their families endured not only the grief of loss, but the particular anguish of waiting, knowing exactly where their loved ones were, and being unable to reach them. One wife had received the terrible closure of watching her husband's body recovered the same day. The other families did not have that. The instability that made this building so lethal on the way down made it equally lethal for the people trying to bring workers home afterward. New Orleans in 2019 was not an outlier in terms of municipal building department capacity. Across the United States, city inspection departments operate under chronic understaffing, compressed approval timelines, and political pressure to keep major development projects moving. Developers on projects of this scale carry significant economic weight in local economies, and that weight translates into informal pressure on city agencies to approve, to sign off, and to keep the schedule intact. That pressure does not always manifest as explicit corruption. Sometimes it simply means inspectors are spread too thin, visit too briefly, and sign paperwork that reflects the schedule rather than the site. The GPS evidence that exposed Eric Treadaway was not the result of a sophisticated investigative system. Local media obtained vehicle fleet records that the city already possessed. The technology existed. The data existed. Nobody had looked at it in relation to the inspection logs until after 3 people were dead. GPS tracking of municipal inspection vehicles is technically straightforward and not expensive. It requires a policy decision, not a technology investment. The fact that most jurisdictions still do not cross-reference vehicle location data with filed inspection reports is not a technical limitation. It is a governance choice, and the Hard Rock collapse is what that choice looks like when it goes wrong. In 2026, developers across the United States are navigating a high-interest rate environment that has fundamentally changed the economics of mid-rise construction. Every month, a project sits unfinished costs money at a rate that was not modeled in the original feasibility study. That pressure creates a very specific incentive: find savings inside the building itself. Change orders get issued, specifications get revised. A structural engineer of record gets a call asking whether a lighter beam profile could work in a particular location. Sometimes the answer is yes. Sometimes the answer is yes when it should be no. The hard rock beam redesign is what happens when that process runs without adequate oversight or verification. American Concrete Institute Standard Number 347 is not a new document. The 21-day minimum curing requirement before temporary support removal has been codified engineering practice for decades. It exists because the behavior of concrete under load during the curing window is well understood and well documented. Freshly poured concrete does not achieve design strength on a linear schedule. The first few days represent a fraction of the eventual capacity. Removing formwork and shoring at 3 days does not mean you get 3/20ths of the safety margin. You get far less than that, because strength gain accelerates as curing progresses. Whoever made the call on October 7 either did not know this or decided the schedule mattered more. What would systemic reform actually look like in practice? Third-party inspection firms, independent of both the city department and the developer, contracted to verify structural milestones before work proceeds. Digital concrete pour logs with time-stamped photographic records tied to GPS coordinates, creating an auditable chain of custody for every critical pour. Automated curing timers integrated into project management software that flag any support removal scheduled before the ACI minimum window closes. None of this is experimental. None of it requires technology that does not already exist. It requires a decision by a city council, a state legislature, or a building department director that oversight is worth the cost of implementing it. Have you ever worked on a construction project or in a field where you knew a standard was being skipped and nobody said anything? I would genuinely like to hear about it in the comments. There are things the public record does not yet confirm, and this channel does not fill gaps with speculation. The identities of the general contractor and the structural engineer of record on the Hard Rock project have not been confirmed in the sources underlying this video. The question of who specifically approved the beam redesign, whether a licensed engineer signed off on revised specifications, and whether that engineer faced professional consequences, remains open. Criminal charges, civil settlement figures, and the current legal status of any proceedings as of August 2026 are not confirmed in the available record. Those gaps are not incidental. The GPS records that proved an inspector was not on site are part of a larger paper trail that points directly to decisions. The GPS records that proved an inspector was not on site. The ACI standard that specified exactly how long concrete needed to cure. The structural analysis that quantified the beam overstressed to 300%. The worker testimony that placed the support removal at 3 days after the pour. Every single failure point in this collapse is documented. None of it required investigatives' heroics. It required someone to pull the records that already existed and read them in sequence. Every collapse has a paper trail. You just have to know where to look. And in this case, the trail does not lead to a mystery. It leads to a series of decisions that were made by people who knew, or should have known, exactly what they were doing. Belter Bermudez was a steel worker. On October 4th, he watched concrete being poured on the 18th floor. On October 7th, he watched the temporary support posts come down. He was on the 17th floor on October 12 when the structure above him began to move. He survived. He also gave investigators the precise timeline that transformed a catastrophic event into a documented violation because he had been there for every step of it. He was one floor below the failure point, close enough to see the decisions being executed in real time, and close enough to nearly die when those decisions exhausted the structure's remaining capacity. His testimony is the backbone of the curing violation case. She rushed to Canal Street when she heard. She told people she would wait as long as it took. And in one sense, she did not have to wait long, because her husband's body was recovered that same day while she stood there. That is a form of closure that the other two families did not receive. The collapse was severe enough and the rubble unstable enough that recovery operations could not proceed safely for an extended period. 3 workers died in the same event, in the same building, within seconds of each other. The timeline of their family's grief was determined entirely by where each man happened to be standing when the 16th floor gave way. That is what a structural failure at this scale actually means for the people inside it. 112 workers were inside 1031 Canal Street on the morning of October 12. 111 of them got out. That number is sometimes framed as a near miracle, as evidence that the collapse unfolded slowly enough to allow escape. But look at it from the other direction. The structure failed fast enough that 3 people could not reach safety. The fact that the majority escaped does not indicate a controlled or survivable failure mode. It indicates that the geometry of where people stood, the path they were nearest to, and the sequence of floor failures happened to spare most of them. The margin between 111 survivors and a mass casualty event was not engineering. It was proximity. The American Concrete Institute published Standard Number 347 because engineers already knew what happens when you remove temporary supports from under fresh concrete. That knowledge existed before the first beam was redesigned on this project. The 21-day curing requirement existed before October 4. The requirement that a licensed inspector physically verify structural conditions existed before Eric Treadaway filed a single report. None of the standards that were violated at 1031 Canal Street were ambiguous or newly introduced. They were established, published, and accessible to every person involved in this project. This was not bad luck. This was a series of choices made by people who had access to the correct information and proceeded anyway. The project was planned as the Hard Rock Hotel New Orleans. It was marketed under that name. It was permitted under that vision. But on the morning of October 12, 2019, the Hard Rock signage had not yet been installed. The building collapsed before it was ever branded. Ribbon was cut before the first guest checked in, before the event space hosted a single function. The hotel that was supposed to represent a new era for Canal Street never existed in any operational sense. What existed was a construction site that had been pushed past the limits of its own structural design, and the name that was going to go on the facade was waiting in a warehouse somewhere while the building fell down. Every city in the United States has a 1031 Canal Street in some form. Not a building that has already collapsed, but a project where the beam specifications were revised to save money, where the inspector's visit was logged but not verified, where the concrete schedule was compressed because the developer needed to hit a delivery date. Most of those projects finish. The building goes up, the ribbon gets cut, and nobody ever looks at the change orders or the GPS records because there is no reason to. The Hard Rock collapse did not reveal an unusual failure. It revealed the normal conditions of a construction industry operating under schedule pressure, cost pressure, and regulatory systems that depend on human presence to function. Somewhere right now, a concrete floor is being poured on an upper level of a building that will eventually open to the public. Somewhere, A structural engineer is reviewing a change order that asks whether a lighter beam profile will carry the load. Somewhere, an inspector is filing a report for a site he may or may not have visited. None of those people are necessarily acting in bad faith. Some of them are under enormous pressure. Some of them are working within systems that have never been designed to catch the specific combination of failures that brought down the hard rock. The question this case leaves open is not whether those conditions exist. We know they do. The question is whether anyone is checking. If this breakdown gave you something to think about, subscribe to Kevin's Collapse Files, because this is what we do here. We pull the documents, we run the numbers, and we follow the paper trail until the story makes sense. If you have a project in mind, a building, a stadium, a bridge, a tower, that failed in a way that never got properly explained, drop it in the comments. And if you want to go deeper on structural failures right now, the playlist is linked on screen. Every collapse has a paper trail. Let us keep looking.